Ah! Oh, Jared. Good morning, everybody. How the heck are you guys doing?
What?
Say good morning. Kevin, I think you're on mute. Something happened to your
Yeah,
mic.
my main mic I turned off. I've been talking and saying hello and
Good morning. Good morning. Good to see everybody today. We got all sorts of people in the chat. Christina, Belinda, already talking about exchanging recipes. Pretty soon we're going to have a new channel, Kratos Bakes. That's Please stay tuned for that new we'll be doing all sorts of recipes from the field, and yes, we've
does does it
Christina has her
only have
GitHub
to
recipe out. What's
does
that,
it
Kevin?
only have to be baked? I mean, I hear somebody does brisket now, so
Oh, yes. Oh, that's true. Maybe we
Ooh.
should not. Kratos BI eats. There we go. Well, or Kratos eats. There we are. So it wouldn't be business intelligence on eating. That would be disturbing in so many ways.
I got a full chicken I got to smoke this afternoon for some guests coming over tonight. So
Ooh, that's exciting.
yeah,
Well, good morning, Jared. How are you doing?
Uh, doing wonderful. Doing wonderful. Having a wonderful day. Kids are off to school, so now I get some peace and quiet. Get to spend it here. It's a great way to
Awesome,
spend the
awesome,
morning.
excellent. Good to see you here. Do you want to introduce yourself?
I mean, if I have to, so I was raised as a small child on a farm, and okay, probably too far back. Jared Kuehn, also known as DataBard, been kind of new to the community, getting back into public speaking for the past year or so, but been working as a data consultant for well over 10 years now. Those who care about certifications, I have them. But really just love solving logic puzzles, love being a data bard, which is kind of logic puzzles, and it's about storytelling. So stuff like this is a great opportunity to flex both muscles and have fun while doing
Yeah,
it.
that is
nice.
fantastic. And honestly, we saw this presentation at FabCon. So, right when you got done with it, I said to you, we've got to get you on the show so we can like run through this because I'll admit I've had people try to explain PySpark to me on a number of occasions, and I didn't really get it until you kind of started to break this down. So I'm real excited for this conversation to get into that. So, um,
Well, I didn't attend at FabCon, so this will be new to me. So
excellent.
I know, right? I
There.
don't know who was
On.
against you, but I made other choices. I
There was so much good content. There's like what was it, 19 different sessions
Yeah,
going on at
yeah,
certain points. Like,
that to me
yeah,
was just a little bit too much, right? You have 19 sessions in an hour block to choose from. It's a little overkill, but
Well, there were what 7,000 people there. Like,
yeah, 6,000, 7,000, something like that. I mean, I get it. It's got to be, kind of broken up, but there was so much good things that you just couldn't get to because of that. So,
well,
um,
and that's why I'm excited to have Jared here to do this. Stay tuned to this channel. Mark Lavelle, he did a recording for the Mass and Fabric user group on his presentation of using Copilot in Fabric today, and it was a fantastic breakdown of all of the different copilots that are out there. So that recording is going to be going up next week. So
hmm.
stay tuned. Hopefully, we can start to like bring some of these presentations to light and get people to see that stuff. Um, yeah, do all of the presentations over the next year. Okay, we'll see what we could do there, Jack.
so, yeah, so new thing. Fabcon picks their presentations, and then Kratos has. This is how
Yeah,
my channel will go. Everybody will get their presentation recorded here. We'll get them recorded one way or another.
yeah. Oh, and if you did a session and you want to be on, happy to record it either live and have you on Fabric Fridays right here, or do another conversation. So let me know. Reach out. I don't think I'm shy or unapproachable. Hit me up on LinkedIn, X.
Not at
I
all.
just posted to Reddit this morning, so apparently I might be on Reddit now. So
Nice.
yay, Reddit.
Yay!
I like Reddit now.
All right. So we've been chatting. Oh my gosh. Okay, so Adam says he might be able to make that happen. Well, hit me up. We can do that. This is fun. Let's throw the
Start
gauntlet
hatching.
down. Let's make that happen. All right. Like, why the heck not? Let's be aggressive in this world. We only get to go around one time. Let's do these things. All right. All right, Jared. Let's dive into this topic. Can you explain to me and to the audience, like, what the heck do we mean? I've heard of Spark. I've heard of Python. What the heck is PySpark? Is it like the Reese's peanut butter cup of data engineering?
It's a grateful union is honestly the way that I try to explain it to people. You think about a lot of the conversations that go on in the world of data. And I mean, obviously, SQL is the workhorse for a lot of our solutions for many years, right? People like the language, fourth generation stuff is great. And then people are like, but unstructured data. And then Python explodes and people are building libraries and data frames show up and all these wonderful things happen. But then Python really starts getting into a certain limitation. And I'll say at least trying to keep up with it in the industry, things have improved, but there's one consistent issue that Python runs into. Python runs into performance issues with large data sets. Like you can do a whole lot of things with it. You can build a super beefy virtual machine that has a whole bunch of memory and let Python do its thing. And it still hits a limit when you're talking hundreds of millions of records. So then we get Spark, which shows up with distributed computing. They're like, hey, this is wonderful. Yay, distributed computing. We take our data, we partition it because we love our partitions, right? And we take our partitions and we say, hey, instead of doing all of our partitions on one computer, let's get like 20 computers and 20 partitions, and let's have each computer do its own thing, and we'll bring back the results into a central location. That's Spark in a nutshell. But then people are like, Spark is great for distributed computing, but Python libraries, all the stuff that's been built out there has been helpful. So what did people do? They built a Python API for Spark, and there you have PySpark. That is PySpark in a nutshell. It's purely an API for running Python in Spark.
Okay, well, that makes perfect sense then.
That's about it.
Yeah. And because it is an API, what I always found interesting looking into it, maybe you could help me understand this a little more, is like I always think when I'm writing code, right, it's executing one line at a time or whatever. But I think there's efficiencies built into it that it kind of batches some things up, right, and sends it off to there. So you could get even better performance out of it than the way like somebody like me would write it, because the interface to call the API is that good. Have you seen the same?
Yep. Yeah. Actually, so I at the Fabric Online conference earlier this week, I just gave a talk talking a little bit more about this. So what is interesting when you're working with Spark is it really challenges what we consider a transaction, because that's a lot of how we think about working with data. Is like we want to do transactions, ACID consistency, all those things, right? Well, we think about at least a lot of more like third generation languages, your Pythons and whatnot. And it's more like we expect each line of code is its own separate transaction. Not so true for Spark. Spark blurs the lines a little bit with a concept they call it lazy evaluation. Essentially what it means is you can write a whole bunch of lines of code in Spark to do things. Spark will not actually try to do anything until typically you're doing one of three actions. You're writing data to a file, you're trying to print data to a console, or you're trying to do an aggregation. When you perform one of those three actions, that's when Spark starts saying, okay, now I have to do something with this. And then it takes basically everything from that point before and builds an execution plan of how to try and do that effectively. And there it's trying to do an execution plan similar to what we're used to in.
Okay, so my code would be really bad if I did a line of code, and displayed my data frame, did another line of code, displayed my data frame. So be kind of intentional on where's a good point to display it, right? And I do always kind of encourage, and I don't know exactly why, but now maybe it was a good thing. I encourage, hey, let's not always display this, especially when we're ready for this to go into the main working branch, right? Have strategic places that, if it's going to help us debug a problem, then yes, we could display out the data frame, but let's not overload the output. Because to me, if you get something that errors off in production and you're trying to go through the snapshot, oh, well, I don't need to see the data at that point. Or sometimes you go, I wish I could have seen the data. So,
yeah, and I would say that for sure holds true. And actually, we'll see. I actually do have a demo where I showcase that of showing just the difference of like one display and one aggregation takes working with a particular data set without or with those steps being done in the appropriate spot. A process can run in about 4 seconds. If you move it further along where it essentially has to make two execution plans, one for before the event and one after, can take upwards of 20 to 30 seconds just for that one difference.
And that could be a big deal, especially if you're looking at how you're incorporating your data pipelines with validation checks and your bronze, silver, gold, and your time to delivery, and as we start to approach more integration with RTI, right? The expectation is going to be much shorter run times and not these big 8-hour load processes, right?
Yeah, you do really have to think of it in terms of, even if you're going in the direction of real time, the actions you take, you still want to think of them in a batched mindset. So it's still you don't want to just do action display, action display, action display, action display. It's figure out where you want to record a state of the data partway through your process. Focus on that exclusively, and then if you want anything else in your code for debugging purposes or anything like that, keep it there. Just comment that out a little bit, unless it's absolutely necessary in your production workloads.
Yeah, hey, I think that makes a great deal of sense, but I'm wondering if we're skipping the lead on this. One of the things I like most about your presentation, Jared, is you had a great intro to really break down the basics of that. Do we want to start and go over some of that stuff?
Sure. Why don't we kick off into that? Yeah, and I mean, even while we already covered a couple of the topics, but I'll launch through the slide deck pretty quick there. I don't like doing a whole lot of slide heavy things, but at least make sure we cover a couple topics there. That's my face. Nobody needs to see that. So, I mean, again, why are we doing PySpark? PySpark is about getting the flexibility of Python and all the libraries that exist there, but with the distributed performance benefit of Spark. And admittedly, I think I saw somebody talk about in the chat of how high do you need to get up there, and I agree with the sentiment. We're talking the space of hundreds of millions of records to billions of records. That's really where you're going to see the difference. And some of it does depend a little bit on the way your Spark clusters are defined. So at least we've got that. I at least have my fun little cheat sheet for people in case they have any questions about things. The main thing I like to highlight here, though, is data frames are incredibly important, because when I give this talk, it's twofold. One part is we're using PySpark to give us better performance. The other part is we're talking Microsoft Fabric. And the question you should always be asking yourself when talking Microsoft Fabric is, what does Fabric give me that makes it easier for me to do what I'm doing? And in this case, the secret answer when you're working with PySpark is data frames are incredibly important, especially using the, we'll say, correct data frame. You can argue back and forth between whether Pandas makes more sense or Spark are the two common ones. secret answer is try and work with Spark unless absolutely necessary, or unless your data is reasonably small, then you can work with Pandas data frames.
One of the things I found interesting from your conversation, this slide here, is the right before the data frame, I didn't realize this, is that the indents are, not just a nice thing for reading, but can you explain how the indents are work again?
Sure. So the indents are necessary. So that's not just a suggestion. That is where the Python language, and it translates into PySpark. That's the way the language works. Indentation is how it defines scope of code. When we think about third generations, we talk about like scope of defining functions, of like if else or case statements, try catch, looping situations are all consistently there. And sort of the interesting thing about notating that in Python, and again, that translates into PySpark, is it defines the scope by the indentation. You can kind of see here on the screen that I have just a basic function call here. Actually, can I zoom in here? Yeah, I can. So you can see here, I've got a basic function call, which is doing a hello world, or in this case, hello name. I can pass in a variable value. But what Chris is talking about is, notice this line down here is indented. If that line is not indented, this function does not work. And when the function defines that the function is over and we're moving on to something else, is when this next line of code is no longer indented. Could be comment, could be actual code. Either way, it doesn't matter. But as soon as that indentation is done, the function, the scope changes back to more of a universal viewpoint. So if you like having everything, no indents whatsoever, you're going to have to pick another language, to be perfectly honest.
No more semicolons or whatever, or closing brackets or anything like that. But yeah, it took me a bit to get used to the indents as well, from coming from other languages, but it's fine.
I think the other thing that consistently, that consistently trips people up, and it's this item down here about variables. If you're new to working with Python or PySpark, be ready for your variables to be literally anything. Like the definition of a variable is purely a name, and that's it. So if you want, like, and I actually did a video series a couple weeks ago on showcasing this. Like, you can define a variable of like a string type. No, that's not the best use case. Something like an integer. You can change it to a string. You can change it to an object. You can change it to anything you want. Python and PySpark is not going to care. It's going to let you do any of those things as long as the way you use the variable still makes sense with whatever you pass into it. It's just a little bit weird for those who like other languages, where especially SQL, we like our data types, right?
Yeah.
Python just
not. We've been using them to help us with common functions that we have, right? And that's where I kind of realized, that's exactly what that's doing. I didn't realize a variable could be a function. So we're trying to rename functions but not break other code, so we don't have to change everything at once. So rename the function, but then make like an alias by assigning the old name to the variable, as a variable to the new function, and then slowly change out the code from there. It's been working well. So yeah, that was one of my things that I came across going, wow, that's different. I thought of it like you said at first, is it had to be a data element, or a strongly typed type of thing. So
yeah, sure. I think Python is super unique, and I could see why people really like it. And I'm just really put my big toe in the water, trying to get used to it and stuff. So.
It's a really fun language. Like I've been trying to learn it, especially in more detail within the past 2 years here, and I feel like each day I'm learning brand new things. Especially like just trying to keep up with all the libraries that the community is building has been like the one advice I give for people is, if you're looking to get started with Python or PySpark, before you write anything, do research on what the industry is doing, and if anybody's built a library that makes your code easier. If it does, make use of that, because that's, especially working with data, those workloads are going to be very library intensive, and that's with purpose. We love working with data. We love working it in similar patterns. Libraries help with that.
Well, that's fantastic. You know what else helps with coding? And that's NeuroGum. NeuroGum is not a sponsor of this show, but holy cow, if you're looking for help in programming and software design, you should check out NeuroGum. You can pick up NeuroGum online, or all I know is online. So you should check that out. It's fantastic.
Okay. Wait, should we do it now, or should we wait till the end of the
Yeah,
live
why don't you
stream?
wait till the end of the show? You know, we're not affiliated. I don't have affiliate links or none of that stuff. So
maybe you will be. We're still
yeah,
trying to
yeah.
get
If
Buffalo
you're at
Trace.
NeuroGum
So.
and you're like, hey, we love a plug from a developing area, like this is a good spot. It's fantastic. So.
I feel like I'm concerned, but I don't know.
No,
if
if anybody
concerned.
watching, like, that was a surprise to all of us. So.
Almost.
Well,
almost.
not you. Maybe it was a surprise to me. Maybe Jared was in on it.
Yeah. Well, we like to keep things nice and fresh here. But Jack's got a question here. He's asking, thinking about libraries, where do I find a source that will tell me what's available? Like, are there 3 million? How many are there? Where should I go? What are some good libraries I should be using?
Oh gosh. So I'd say at least some of the more public areas to get libraries is PyPL. PyPL is a particular location that, and especially for Fabric, that's a good one to know, because Fabric, if you build custom environments to work with PySpark within a Fabric, environments gives you the ability to pull libraries in from PyPL that are not immediately available in the Fabric environment, which the default Fabric environment has a fair amount of libraries available. I'd have to look.
Is it PYPL or PYPI?
PYPL.
The one that I'm finding is PI.
Or it could be a capital I. I could be wrong.
Yeah,
I thought people said PyPL, but it could be
it's PYPI is the Python index.
Okay. Yep, that's the one. Pay attention to nothing I just said. It's PyPI.
There you go, Chris. If you want to push that out,
so that would probably be the biggest thing there. And I mean, obviously, beyond that, theoretically, you could always build your own custom libraries and upload that into Fabric. That is also an option.
All right, it's pypi.org. Right. Oh, there we go.
Oh, it's gum with caffeine.
Yeah.
That's the reason.
Yeah. It's got caffeine, L-theanine, vitamin B6, and vitamin B12. So it's going to lock you in.
How much sugar, though?
No sugar.
Really?
No sugar, no calories.
Sugar.
Wait.
Everybody waiting in anticipation.
Yeah. Why can't I read this? I'm blind.
Exactly what
I don't think there's calories.
There's none that count.
Right. Not when you got this much caffeine coursing through your veins, it don't count.
Just chewing gum, and then you start chittering, and then that means you're chewing faster, and then it's more release.
Right. It'll get you going. So
yeah. Well,
all right, let's keep going.
Let's keep going. See in the chat, right? And Mim is bringing up DuckDB again, and it's one of these days, Mim, because I follow you and read about it, but I'm gonna look into it. So probably needs
Mim,
to be soon.
you just got to come on the show and show us what the heck DuckDB is. Like I don't know how to import a duck into Fabric. That's just it seems like a challenge.
So there's a challenge, Mim, to come on the show and teach it to us.
There you go. We're throwing down a second gauntlet today. All right,
Jared.
let's talk about this fabric admin topics you got up here. Can explain this to us?
Sure.
Right?
Yeah. So under assumption that most people who want to work with PySpark, you're not going to be your own fabric admin, which is unfortunate, but I suppose security serves its purpose. Obviously, some things that you want to talk about with your fabric admin to make sure that they make your life easier when working with fabric. And two main things you need to know about. First of all, at least is your Spark pools, at least not including the auto scale announcements that came up as part of FabCon. So this is technically a little bit outdated. And I'm super excited for the auto scaling because actually it's going to be really good. But if you're not working in an auto scale situation, this is your world. The size of Spark environment you can create is entirely dependent on your fabric SKU. You can see from the graphic here, your SKU determines how many vCores, which determines essentially how many nodes you can create. It also restricts the size of nodes, which if you find yourself in a situation where you want to work more with Python and you want to work with like pandas data frames, that's especially important because something like an F2 or an F4 SKU only gets like 4 to 8 vCores. I'd have to double check my documentation on it, but I think the largest node you can create is an XX large, which I want to say it's 32 cores, but the memory size is pretty significant. And that's actually kind of the big restriction here, especially when we talk performance. So talk to your admins about capacity, and then we were already talking environments there. So work with them to define a custom environment if you need it. Because especially if you're needing things like libraries from PyPy that are not innately available in the Fabric environment, you're going to want to get those in place so that you're not having to constantly import them or pip install them every time you run your solution.
Well,
and if you don't configure things appropriately with your admin, you're going to run into that message at the bottom of the screen that says the Spark job can't run. Means you're trying to spin up an Apache Spark cluster, and we have to remember we have to spin up Apache Spark. It's not running 24/7. If you spin it up, you hit that message, your capacity either isn't large enough or somebody else is doing something that is messing with what you are trying to do, and got to talk to your admin about your cluster configurations.
No.
Too much gum.
Okay. A running gag. All right. Yeah, that's enough of that. Let's start. Let's at least
There we
show
go.
actual
We're at the
environment
halfway
stuff.
mark. Let's get into some code here, right?
Yeah, it's good timing.
And hang on a second here.
All right. So
DataMonkey
Okay.
says there's 64 cores with half a terabyte of RAM. What has 64 cores with half a terabyte of RAM?
that would be the maximum node size I think you
okay.
can create with it. But again, in order for that to work, you have to be working on a capacity that has at
Okay.
least 64 cores.
Makes sense.
Fair enough.
But yeah, that's sort of if you want to work with more of a, like I said, pandas data frames, it really is going to be restricted more so to single nodes. So if you're still sitting there wanting to work with pandas and you want to load that data all into RAM because that's going to be most performant working with pandas, you'd be looking to try and create a 64 core, or at least the largest node that you can create. At least we'll get that pandas data frame the most power possible.
Right, excellent. All right, so we're new. You've kind of explained this to us. Can you start running me through this notebook and show me how, like, even what the heck a notebook is? How would I use PySpark in it? Right.
Sure. So at least brief blurb before I get too deep into that. What I'm showing you today is on my GitHub repo. So if people want this actual script that I have here, which also includes a sample file that I generate for sake of demonstration purposes here, feel free to use it out there. It's there for demonstration purposes, and for the most part, it should theoretically self-build itself, unless I broke it. There we go. But anyways, talking PySpark and Fabric, unless you're working in more of a focused automated situation where you might use Apache Spark jobs, most times you're working with Jupyter notebooks. In case you're not new to, or in case you are new to Jupyter notebooks, main benefit there is when you're working with your data and your code, rather than having a single file that you have to run every time you want to debug it, Jupyter Notebooks breaks it down into individual cells. The cells you can run independently of one another. And more importantly than that, you also get an additional type of cell called the Markdown cell, which if you like working with Markdown, means you get documentation right in your notebook, which is nice because especially like you have to think about Fabric. Fabric, we're likely going to be working in more collaborative environments. You always want to assume somebody's going to read what you wrote. Best to have some documentation immediately there so they know what they're looking at. For me, at least, this notebook has my own script here because I have a horrible memory to remind me of what I actually need to talk about when I showcase this notebook. So a couple things here. We want to talk about attaching lake houses and warehouses. So first of all, actually, let's take a step back. How did I create notebook?
Before you take a step back, so you could put documentations in the Markdown and you could put comments in. What do you think of a good what's a good balance on that? I mean, I would kind of like to push to go, hey, all documentation goes up in the Markdown because I think you could format it to read a little bit better. And then you're only using comments to put code in and out, or maybe call out something. If I'd like to also say cells, think about them to be as small as possible, right? So what do you think about all that?
I would agree with that sentiment. The focus there is like Markdown has a bunch of formatting and additional things to make it easy to read things. And you think about how we solve that in non-Markdown environments. It's like really long strings of the comment character for your language, and then maybe some extra like pound signs here and there to delineate things. And we're doing ASCII art for all intents and purposes. Right. Markdown lets us take that additional step, and I think that enables us to create documentation that's more readily available to a wider audience. So something like, I need to make sure that whoever reads this notebook understands the general purpose of what this notebook is trying to achieve. I could do that in comments, or I could do it in Markdown, which makes it a whole lot easier to read. Right. And I would say then that comments then you kind of relegate to just focusing on if there's a particular line of code that looks weird in the context of the in, maybe there you add in a comment that says this line is here for this reason.
Yeah. I like inline comments inside code. The rule for me has always been if you're doing something very complex or unusual with like business logic or some functions, I want it explained in line what you're doing to not screw over future self. So that like a week from now, when you go back to the code and you're like, well, why the hell am I calling this new data science function here? That doesn't make any sense. And you can remember what the heck you're thinking, right?
Yeah, I think it's got to be a good balance. Like, the business logic, the business rule is up in the Markdown, right? And and then, like Jared was saying, is down where you're going, hey, this is an odd part, and I'm using this to help implement that part of the rule or something like that.
Yeah,
I think is a good balance. The other thing I like is when you do Markdown and you do your headers correctly, you go to the view on the notebook, and there's a view part to see the table of contents. It's just automatically generated. And I use that all the time to navigate myself on some long notebooks to go, oh, wait, this is the part I want to look at, or I want to see how this was done over here. So that's helped tremendously. So, yeah, John is talking about PEP8. I think, did you mention that on an earlier slide? It has guidance around the comments and identifying code changes.
So you could talk to PEP8. If you don't know PEP8, he's a great guy.
Pepe Le Pew.
What's that?
Pepe Le Pew.
He is a skunk. But sorry, we like totally interrupted your demo here.
Yeah, really.
What are we doing again here?
So at least taking a step back of like, how do you create the notebook? The one thing I want to make sure I call out here is if you search for notebooks, like by creating a new item, just know you're going to see 4 different items in here. They're all the exact same thing. So don't expect that like, oh, I have to pick the right notebook. No, they're all the exact same notebook. And you create that, and then suddenly you get this. And of course, it's not pre-populated because this is a cooking show with gum that I prepared earlier.
to tie everything or bind everything together.
Yep. Yeah, gum's a great binder I found for baking. It's really nice. So let's talk about some of the things that you can do with a notebook that makes your life easier. So we're talking Fabric-specific features. Some of the things to call out here are lovely Explorer on the left. What do Explorers on the left of our IDEs typically do? They give us context. And for something like Fabric, actually gives us context and more. So anything we can define as like data items, resources would be, if you do additional libraries and such, would show up in this section here. But notice I can initially get, in this case, I have a lakehouse connected into my notebook. And I get a list of all the tables and all the files and all the structured and unstructured data that I want to work with. But that's just viewing it. What benefit does it give me? This is where I have to do the PySpark demo that everybody has to do anytime you're doing a demo of a Fabric notebook. Behold, I can drag this over into a cell, and lo and behold, it generates code.
Yay!
Yeah.
This is now the conclusion of the demo that everybody's legally obligated to do every time you show a Fabric.
I'm glad you showed it as the drag and drop because I'm still old school and used the 3 dots before they implemented the drag and drop. So
the drag and drop is nice. Just notate what we talked about with lazy evaluation. Notice what it generates as part of the drag and drop. So it's great to get started. It's great for more notebooks you expect to like share in an interactive experience. Production workloads, use this carefully. But at least something like that lets me do this and generate all of this. And also notice that it did it in PySpark. How did it know to do it in PySpark? Well, 2 things. One, each cell has its own definition of the language that we use, and it is right here. Each notebook also has its default language, which is notated up here in our lovely section up here. All right, so this is your default. What we can do cell by cell is we can override that. So I can go in here, add a new cell, and do the same legal demo again. Oh, wait, now I got to shift my language first. Otherwise, the demo makes no sense. There we go. So I'll shift to like Spark SQL because maybe we want to do SQL stuff. Drag it over here. Ooh, it changed language context. It's that smart and that easy. Wow.
Bum, bum, bum.
But wait, there's more.
But wait, there's more. Suppose I don't actually want to do the same thing twice. Well, I get this lovely section over here on the right that is a cell. Hey, stop scrolling. My Zoom is fighting with me today. There's this lovely section over here that gives us things we can do specific to this cell. So I can hit the ellipsis and do a bunch of things here, or I can do delete cell because now I've got 2 redundant cells and boom, it's gone. All those situations where like deleting cell or deleting code means, oh, I have to make sure I pick the right number of lines and I can't pick too much or otherwise I break my production code. You organize things appropriately by cells, click, it's gone.
Yeah.
All right.
Yeah, that's one reason I encourage people. Yeah, think the same way, right? Think like a logical block of you're doing something, and it should be kind of short, and keep that into a cell. If you have a cell that's 100 lines long, you probably have a problem. So,
Yep.
Not always, but probably.
Probably. Keep it simple, right? And part of it is keep it segmented. All right, let's see. So, fun thing about at least notebooks, and if you're new to PySpark, or really if you're new to Spark in general, all right, I've got a bunch of code here. I want to actually run something. Well, Jupyter Notebooks gives me the run cell buttons down here. I can run cells individually. I've got a run all button here. Notice I've got this connect button up here. What's this all about? Well, you have to remember we're in Apache Spark. If you're used to more of a database world where we even think cloud, like storage and compute are often separated so that sometimes we can turn the compute off. But a lot of times for databases, we keep our compute, for the most part, running all the time, right? Apache Spark is the reverse. Apache Spark doesn't want to have you run compute unless you need compute, because in this case, you're creating a lot of compute in an Apache Spark cluster, and that could be expensive. So when we get started with notebooks, we have to make sure we know, just because I have this notebook open doesn't mean I can do anything. So I'm going to go ahead and let's hit this, and we're going to start up a session. There's an option here, standard session, high concurrency session. The difference between the two is compute isolation. Standard sessions are used by a singular notebook and a singular notebook alone. High concurrency sessions, you have the option of defining one session, and it could be used by one to many notebooks. That's the difference between the two. We'll start up a standard session, and we're using the workspace default, so standard compute.
So, Jared, why wouldn't I always want a standard session so I'm isolated from everyone else?
So probably the biggest thing you'd want to talk about there, and I'll at least freeze this here because I want to talk about this after this point. Why you might want to use high concurrency is, suppose a situation where you're doing an ETL process and you want to, well, I guess at least two scenarios. Well, actually the first one, never mind. Don't pay attention to that one. Biggest reason here is if you're looking for an interactive experience with your notebooks and you want to work with multiple notebooks at the same time, and you don't have enough Spark compute to create a cluster for each notebook. That might be a situation where you create a single high concurrency cluster, and then each time you start up one of your notebooks, you connect them to the same session, and presumably you're not running two notebooks simultaneously, or even if you are, it should be able to work with both of those at the same time. Probably the other consideration is some ways that I believe you can orchestrate running multiple notebooks as part of an ETL process. There might be situations where you're wanting to run multiple notebooks. You don't want each of them to have their own separate compute. So in a case like that, you might try and allow high concurrency and make sure you set up one high concurrency node that's used by all of the notebooks.
Do I have to worry about, like, let's say I'm on a team of 20 people. Do I have to worry if we're all running, not, the single use version? Am I going to lock myself out, or am I going to find that there's no resources available for me if I'm doing that versus, if I do the high capacity, we can all be running stuff all the time, and we're only limited by the amount of CUs available?
The high concurrency, and this is where I've heard some people suggest that this isn't true, but based on Microsoft documentation and my own experience, high concurrency nodes are exclusive to a single user. So high concurrency sessions cannot be shared by multiple users.
Okay.
So in a situation like that, it is purely for singular users. And in the case of, like, if we were to decide we need to use high concurrency for orchestration, everything would need to be running on the same service account. So expect that at least in a multi-user scenario, they're going to be working with their own separate clusters all of the time. And that's where, again, talk with your Fabric admin to make sure that if you're expecting to have 4 developers, make sure your pools are set up in an appropriate configuration that allows for concurrent Apache Spark pools to be running simultaneously.
Yeah, exactly. Because I have a situation where I've done development on an F2, and even just what I'm doing myself, kind of testing a couple of notebooks at a time. If I didn't stop the other session, I would lock myself out, basically. Like I couldn't start the next notebook. So when I'm in that situation, like on an F2, I get in the habit of starting high concurrency for myself. And then when I'm switching between notebooks to test different things, I don't have to stop that session. I could just connect it over and avoid that error. So, but yeah, if you're right, if you have too many developers on a smaller capacity, you could run into the same type of problem. If those developers do a similar thing, they're developing or testing multiple notebooks at the same time, all in individual sessions. And so, even on the bigger capacities, you can teach them, hey, do your own high capacity and keep switching over to it to help everybody out.
And actually, that brings up a good point. One other thing that I've seen, and I'm not entirely sure why this is, but I've at least seen this come up. So notebooks obviously can conflict with one another in terms of using up the Spark nodes that you have available. People ad hoc using the Lakehouse UI to look at their lake houses also digs into that vCore limit. Why, I'm not quite sure. It's been a question I've been meaning to ask somebody who might have an answer, and I haven't gotten an answer on that yet, but I have seen that too, where people aren't able to start up their Spark cluster because somebody else is just looking at the Lakehouse ad hoc.
Okay. That makes sense. And MIM's got some guidance here about not using the default configuration, just use a custom pool. Reduce it to a single node unless you're doing very big data, like really big. I don't know what really big means, but...
That makes sense, but I think it leads into the next thing that Jarrett was going to show, the screenshot that you captured. I think it changes this.
Yes, it does. So MIM does bring up a good point, especially like developers. You may want to give them smaller clusters just so you avoid conflict and you can have them working on smaller capacities. But there is one trade-off if you do custom pools, is it changes what I had happen here when I started up my demo environment. Notice here the session got started in 5 seconds. If you've worked in Apache Spark environments before, this should be a little bit odd because most times spinning up a large number of compute nodes should take minutes at least to get those things up and running. If you use the default or what we call the starter pool configuration within your workspace, it's the default that Microsoft provides, you get an additional benefit that isn't widely understood unless you look deep into the documentation. Microsoft essentially has a very large farm of Apache Spark clusters up and running with default configurations 24/7. If you use the default configuration, rather than spinning up a brand new compute cluster from scratch, you're actually getting connected into an existing Spark cluster. So the benefit here is at least it gets up and running faster, which if you don't want to get too deep into the weeds on fine-tuning your cluster definitions and whatnot, at least here it makes for a better ad hoc experience of just, I can spin it up quickly, I can do a couple things, I can stop it. In my case, really useful for demo purposes, so we don't have to wait for 2 minutes for a Spark cluster to get up and running.
Yeah, and he's saying that the single node Spark cluster will also start in 5 seconds. So we're all going to have to go test that. And I trust me, but,
well, it's 5 seconds. Like, how hard is it? Like, we should be able to test that pretty quick.
All right. So let's actually run things. We're far enough along. Let's run a couple things here. So some things at least that you can do here, like I can run these individual cells and do things like do our select top 100. That's at least if you use the drag and drop experience, what you'll get there by default. You'll also get options for writing data. And let's at least talk about that while we wait for the previous cell up above to run. I want to draw attention to at least these 2 lines here, lines 4 and line 8. Line 4, pretty nice notation for this last section here where it says save, and it's tables, looks like a relative path. This one below it has this big ABFS directory. These are both doing logically the exact same thing. What's the difference? Let's go back to at least our benefits of connecting lakehouses to our notebook. Because we have a lakehouse connected in here, we now have the ability to use relative paths to reference the directory within the lakehouse. So this is pointing specifically at this default lakehouse here, to be specific. This is doing the same thing, but it's doing it via its absolute path, which is how you'd essentially access any lakehouse that is not your default.
Well, that's interesting. So you can access lakehouses in other workspaces then.
You can access lakehouses in other spaces. If you want some more details on that, I actually just made a video on my YouTube channel that calls out how you do that, or at least an approach. There's multiple, with all the libraries that are available, there's multiple approaches you can take. But check out my YouTube channel. I've got one example of how you can look at lakehouses from other workspaces.
Yeah, or even still within the same workspace, but there's advantages for when doing development and branching out, because if you use default lakehouses, that stays within the notebook and is carried forward or is carried over to the other workspace that you're trying to do feature development in. So we do a lot where we don't attach, and we use the second method that you showed there consistently in order so that we don't have to keep changing the default lakehouse out. And we isolate a a development environment.
And if you guys aren't subscribed to DataBard, I posted his link to the channel, his channel out there. So do check that one out.
This moment was brought to you by DataBard. Let's have fun with it. So at least one. Oh, sorry, go ahead.
No, go ahead. Go ahead. I was going to make another stupid joke, and it was really bad.
So I at least keeping an eye.
It wasn't worth it.
So at least two more things I want to make sure I call out, knowing at least the time that we have here, is first of all, what do we do in situations like this where, as I call it, Weird Al has taken over my data set, or AKA you're dealing with a low quality data set environment. Some people I know I saw in chat were talking about like looking to get started with PySpark. Well, in a situation like this, there's two things you can do in the Fabric world. One is you can do a bunch of research on what is available in data frame libraries and such to aid you with this. Or you can use a tool that's going to help you learn how to do this called Data Wrangler. What is Data Wrangler, you ask? Well, I'm glad you asked. This is the easiest way to explain Data Wrangler. Think of Power Query for Power BI, right? Mm-hmm. What is Power Query? Power Query is a low-code, no-code solution that allows you to make transformations to your data, clean it up, make it ready for your reports. That low-code solution gets translated into M language, which is then what been talking too much today. That is what the Power BI engine uses then to prep the data for your report. Mm-hmm. Data Wrangler is your Power Query for PySpark. That is truly
so it's a lightweight GUI interface that allows me to just use PySpark without having to know all this stuff.
Yep. Yeah, exactly. To help you generate the PySpark you need, just like Power Query buttons help you generate the M code that you need. Great analogy.
Oh, yeah, it's the exact same sentiment. So the example I can showcase here, depending on how long it takes for this to ramp up. Oh, great timing. We can do similar things to what we do in our Power Query experience. So clearly we've got a duplicate issue here. Weird Al has taken over our data. So let's do this here. And this is where we get the same thing where I hit apply. And in the bottom right here, it's generating a series of steps like Power Query that is going to perform the operations here. So typical demo here, I'd showcase okay, Weird Al, we've curbed Weird Al, at least in terms of this data set. Beyond that, you can't curb Weird Al, it's impossible. But something like age is not a decimal unless you're getting very finitely focused. So something we can do here is a quick change column type. Let's see if it'll let us go to something like float, and it looks like it's not going to let us. So let's go ahead and at least, I don't know, we'll go to, oh, I forgot a parameter.
Oh.
So let's maybe guess we're going in for integer. Nice thing about this is that it's going to make sure it doesn't lead you down the wrong path here too. So something like this, if I try to tell it something that you can't do within a singular step, it's going to say, hey, you can't do this. But then I can still get the same experience by changing it to something else. And then we'll change it again. And here, I believe it should let us change it back to an integer, which is what we want.
Okay.
There we go. Best benefit of Data Wrangler is the whole debate of like, do you go pandas? Do you go Spark? Data Wrangler is going to give you the option to go for both. By default, it's going to generate PySpark code to do everything that we just identified here. You do also have the option to check this box. If I hit add, and it works, should give us two cells here, which logically are equivalent, but the only difference is one is working in a Spark context, the other is working in a Pandas context. Use as directed.
Well, that's fantastic. All right, Jared, we are about at time. I know you've got a ton of additional content out here. I believe you have a video that covers all of this over on your YouTube channel. Is that correct?
I have segments of this covered on my YouTube channel. I'm starting to work on a series where I'm going to start breaking some of these things down into specific detail, and we'll be doing a series on PySpark. Awesome. So stay tuned. This will be broken down.
All right, good deal. Good. But with 3 minutes left, what parting words of advice would you give to the audience here who've been watching us for the last hour?
Anytime you're getting started with a new language, new idea, new concept, just remember you don't have to master it right away. I actually had a video I just put on my YouTube channel about Fabric in general, but it applies to something like this. It's not about at least mastering it right away. It's get dangerous with it, get familiar with it, be willing to break things, because that's how we best learn. And then beyond that,
don't forget you have to clean up afterwards, but yeah.
Yeah, you gotta
Well, just break it in a control area so that you write better code going to production. So
create your code rage room.
Yes.
Break everything in there, and then keep it in your rage room, and then everything else is fine.
Yeah.
And I'd say at least the other encouragement here is the reason Python got so popular, the reason Power BI got so popular, and the reason I hope Fabric continues to get so popular is because of community engagement. And if you're struggling with what to do, get out into the community. There are so many outlets out there where people are talking about these topics and are looking to help other people who are trying to get into this space as well. So if you're new to this and you're not sure where to start, by all means, get out in the community, talk to people. There are people out there who want to help, like myself.
Get on Microsoft's community, join us on Reddit, say hi over there, engage. And thanks for watching this video. You're halfway there.
Amen. That's exactly right. All right, Kevin, why don't you take us out today?
Oh, I wasn't prepared. Well, again, just to follow up, I'm going to just follow up on the community, right? Yeah, you have to get involved in the community. This area, you don't have to, but Microsoft products in general have had strong communities for years, and Fabric just has ridden on the success of that. So come over, see us, come back here, and thank you for joining us. You have the best day ever, and peace.
Tilly Digital combines strategic industry insight and advanced technical expertise to uncover and solve your digital transformation challenges. If you're interested in learning more, check out our website at bakertilly.com/digital.